Hello friends, in this video we are going to discuss the previous year GATE question number 16. This question they have asked in the exam GATE 2005. Let us read the question. The figure shows the voltage across a power semiconductor device and the current through the device during a switching transition. Okay, so here we are having the voltage across device and current flowing through the device during a switching transition. Switching transition means what? Either from on to off or off to on. Okay, is the transition a turn on transition or a turn off transition? Okay, so the first question is whether it is a turn on transition or whether it is a turn off transition, that we need to identify. Second question is what is the energy lost during this transition, right? Energy lost during the transition. Okay, so this is the second question they have asked. Okay, so let us first check the given vi characteristic. Okay, so if you check, v is nothing but the voltage across the device, I is the current flowing through the device. Okay, so if we check here, before this instant, right, before this instant current is zero, right? Current zero means what? Our device is in a off state. Okay, before this instant if you check, the voltage across device is also high. The meaning is our device is in a off state, because when device is in a off state, yes, it is represented with high voltage and low current, right? High voltage and low current. Strictly speaking, the current should be zero. Okay, and when device is in a on state, yes, it is represented with low voltage. Ideally the voltage should be zero and high current and high current. So if we check, yes, before this instant the current is zero, voltage is high. The meaning is the device is in a off state. Okay, and after that the current starts increasing slowly, and after that the steady value of current has reached, right? And also the voltage across the device is decreasing from high value to a zero value. Means if we check after T2, if we check after T2, yes, after T2, yes, the voltage across device is zero, current flowing through the device is high. The meaning is after T2 the device is behaving as an on switch. Okay, means before this instant the device is in a off state, and after this instant if you check, means after T2 the device is in a on state. So can we say that this transition indicates, yes, from off to on, right? Device is turning on, means device is initially in the off state and now it is turning on. So this transition is nothing but it is a on transition. It is a on transition. Okay, so on transition is a turn on transition. Turn on means what? Device is in a off state and we are interested in turning it on. Okay, so the process of off state to the on state. Okay, device is in a off state and we are interested in turning it on. Okay, so the process of off state to the on state switching is nothing but the turn on transition. Okay, so here we can say that this is the turn on transition. Okay, next our task is to find energy lost. Okay, energy lost during the transition. Okay, energy lost during the transition. So now for this, okay, for this, yes, let us redraw the vi plot. Okay, given vi characteristic we are going to redraw v and I. For example, the time 0. Okay, initially the voltage is high and after that it is a decreasing, okay, and reaching to the zero value. Okay, next if we check for the current, it is starting increasing and after that it has reached the steady value. Okay, the steady value of the current is I. Steady value of the current is I. Okay, and initial voltage value is a V, right? This indicates from here to here, this is a T1 they have indicated, and from here to here they have indicated it with a T2. Okay, the T2 they indicate. Okay, next, so our task is to find, yes, the energy lost during the transition interval. Okay, transition interval means what? Between T1 plus T2, T1 and T2, right? T1 plus T2 we can say, from this instant to this instant. This indicates the transition, that is the turn on transition, right? Turn on transition. Okay, so here for this case, as we know, energy is equal to power into time, and power is nothing but the voltage into current. Okay, so for this case we need to write the expression for this waveform as well as this waveform, right? Because before this instant the voltage is constant, okay, and after this we are having a linearly decreasing waveform of the voltage, okay. So how to write the expression for this waveform? And also before this instant the current is 0, after this instant the current is increasing, okay, till t1, okay. So here we can write the expression as this is the linearly increasing. For any linearly increasing plot, yes, graph we are having, or the curve we are having, y is equal to mx, right? Y is the y parameter. Y parameter is nothing but the, yes, parameter on the y axis, okay, and m is the slope, okay. So can we write it as this is the current, right? Expression for the current, okay, expression for the current. So y is nothing but the I here, y is nothing but the I, which is equal to slope, right? What is the slope? That is the change in the y divided by change in the x. What is the change in the y? It is a I, right? So we can write it as a I upon change in the x. Change in the x is t1, I upon t1 into t, right? This is the expression for this curve. It is a I upon t1 into t, okay. Means the meaning is, if we check, yes, here t is equal to 0. Be careful, this curve or this expression is valid only after this instant. This expression is valid only after this instant. Are you getting the point, right? Means for this expression t is equal to 0 means this instant, right? T is equal to 0 means this instant, okay. So here if we check t is equal to 0 means this value will be 0, so that's why it is a 0. At t is equal to t1, if you check, if you replace t with t1, t1 means at this instant, okay. So here I by t1 into t1, so it is a I. So current has reached the I value, okay. And in between, yes, you can check for t1 by 2 etc, okay. So this is the expression for this waveform or the curve, okay. Next, it is a linearly decreasing voltage. So can we write the expression for this waveform? Yes, we can write, it is a linearly decreasing, so slope should be negative, okay. So in this case we can write it as initial voltage, that is a v, initial voltage is v minus, why it is minus? Because slope is negative, it is a decreasing, okay. Slope is nothing but change in y by change in x, okay. What is the change in y? It is nothing but the v minus 0, that is a v, right, divided by x. Change in the x is nothing but t2 into t, okay. So this is the expression for this waveform. You can check it at t is equal to 0. Now this expression is valid only after, only during t2. This expression is valid only during t2, okay. So for this expression t is equal to 0 means this instant, right? So at t is equal to 0, if you check, it is a v minus v by t2 into 0, that is nothing but the v. So at t is equal to 0, this is v, right? At t is equal to t2, if you replace it t with t2, you will be getting v minus v, that is equal to 0, okay. So here we can write during t1, during t1, yes, we can write during t1 voltage is equal to v constant, right? Current I is equal to what? It is having an expression I by t1 into t, I by t1 into t. This is during t1. Similarly we can write during t2, during t2 we can write, yes, voltage is equal to, it is a v minus v by t2, v minus v by t2 into t. This is the voltage across the device, okay. And what is the current? Current is the constant current, right? That is the I, is equal to I. Now our task is to find the energy, right? Our task is to find the energy lost during the transition, okay. So we can write energy lost during transition, energy lost during transition, it is energy lost during transition. Transition means during t1 and plus t2, transition, right, is equal to, right, yes, energy nothing but the power into time, okay, or the integration of power, okay. So we can write it as integration from 0 to t1, it is a v into I into dt, plus integration from 0 to t2, it is v into I into dt, okay. So we can write it as is equal to integration from 0 to t1. What is the v? During t1 it is a v is v only, okay. V into I is I upon t1 into t into dt, plus integration from 0 to t2. During 0 to t2 v is, yes, v minus v by t2, okay, into t into current is I, right, into dt, right. So we need to simplify it. It is equal to, can we take v and I outside. Yes, so it is a V into I into bracket. I am taking Vi and Vi outside. Okay, so we can write it as a V into I am taking it as a outside, so it will be like integration from 0 to t1. Okay, 0 to t1, it is like t by t1 into dt, right? T by t1 into dt plus integration from 0 to t2. Okay, I have taken V and I outside. Okay, so it is like a 1 minus t by t2 into dt, right? So we can simplify it as is equal to V into I into, yes, t dt, it will be t square by 2. Okay, I am writing it as t square by 2 t1, limit 0 to t1, it should be t1, right? 0 to t1. Okay, plus now integration we need to write it as a integration of 1 is it is a t minus t square by 2 t2, limit 0 to t2, right? 0 to, further we can write it as is equal to v into I after putting the limits. Yes, it is like a t1 square by 2 t1 plus this can be written as t2 minus t2 square divided by 2 t2, right? Is this clear? Okay, so 1 t1 will get cancelled, 1 t2 will get cancelled, so it is like equal to v into I into t1 by 2 plus t2 minus t2 by 2, that is nothing but the t2 by 2, right? t2 minus t2 by 2 means what? It is a t2 by 2. Okay, so we can write it as v into I divided by 2 into t1 plus t2. Okay, this is nothing but the energy lost during the transition. I am writing it as a E. Okay, energy lost during transition, it is Vi by 2 into t1 plus t2, Vi by 2 into t1 plus t2. And what is the transition? Transition is on transition, right? So correct option is option A, right? Option A is the correct option. Is this clear? So this is about the question number 16. This question they have asked in the exam GATE 2005. In the next video, we are going to discuss the previous year GATE question number 17. Thank you.